everyone, I'm Trainer Isabel and welcome back to Young Engineers. This is lesson 3 of a 10-part series whereby you learn about science, technology, engineering and mathematics in a cool, fun and exciting way. Let's recap our previous lesson. In lesson 2, we learned about swing chairs and what is centrifugal force. We also designed and built our own swing chairs. And let's give a round of applause to our lucky winners for their best built swing chair model. Now, before the circuit breaker happened, I have a pair of roller skates. But I have outgrew them and I couldn't skate anymore. So, during this stay-at-home period, I managed to take out the wheels and put them onto my new sneakers. Why then do we like to put wheels onto our shoes? Have you ever wondered? Perhaps it's our need and our like to feel moving fast. To feel like we're moving fast. The wind in our faces is very, very enjoyable. Just imagine this, if McDonald's let their servers wear roller skates. That's what I call fast food. But moving along, today we are going to learn about friction. And what has it got to do with roller skates? Now let's try this experiment. Take two of your hands, put them together and rub against each other. This is what we call sliding friction. Because there's two big surface areas placing together, meeting into having contact with each other, and you're moving them against each other. The heat that you feel generated from rubbing your hands together is called friction. Let's give you another example. If you have been to the playground before and played on the slide, after multiple slides, you feel like the seat of your pants get really, really hot. That's because of friction. The contact between the seat of your pants and the walls of the slide creates friction. So far so good, we got the idea. Let's move on to another type of friction called rolling friction. Rolling friction, you can see it in when you're riding your bicycle. The wheels of your bicycle and the contact to the floor. That is rolling friction. Another example could be when you roll your luggage bag or your trolley bag or your school bags with wheels. The school bag, the wheels of the school bag has a rolling friction against the floor. And unlike rubbing your hands, your school bag rolls a lot faster than you rubbing your hands. Why is this so? Because the contact point between the wheel and the floor is smaller. Unlike the two of your hands, they are big surface areas, they contact to each other. They move more slowly. Alright. So, when we have rolling friction, it is drastically less friction than that of a sliding friction. Let's watch this video to better understand the difference between rolling friction and sliding friction.
To begin the activity, place the box on the table and tie a string around it. Attach the hook of the spring balance to the string. Pull the box with the help of the spring balance. The box is sliding. Note the force indicated by the spring balance. Now, place the pencils parallel to one another on the table. Carefully place the box on the pencils. Pull the box with the help of the spring balance. It is now easier to move the box. Is there any change in the force required? Look at the reading on the spring balance. It shows less force.
Now, as you have seen in the video, when you have a rolling friction, it is faster than that of a sliding friction. And the strength or the effort you exert is lesser. Now in this juncture, we'll move on to mathematics. We're going to learn about perimeter. Perimeter is the distance around a shape.
Now we're going to learn how to measure the perimeter of this object. All you need is a string and you just need to go around the object. like this. Once done, you just need to mark it. Okay, and you're now going to measure it with a ruler. So it'll be like that to here. So we have about 10 cm, 20 cm, 20 cm, move it upwards to the next portion, 20 cm, 28 cm. So the perimeter of the adapter is 28 cm.
Let's take this shape for example. We have a field. What is the perimeter of the field? The field is 30 cm. Very good. Why is it 30? Because the formula of a perimeter is this. It's the length of all the sides. So in this case, it's 10 plus 5 plus 10 plus 5. 30. Simple? That's very good. Now let's move on to our model for today. Today we'll be learning how to make a turn basket. So go to Building Sheets, download Turning Basket. Follow the steps to build your turning basket. The steps in red are enhancements you do not need to build if you do not have the time. Once again, before we start building, let's recap on our rules. A young engineer knows 4 rules. They are: only use the parts from your kit, always count, colors do not matter unless they are pins, and always be prepared for class. Are we good on those rules? Let's start building. Now that we have completed building, let's go on for our mission of the day. You're going to turn on the battery pack and you're going to let the table spin. While the basket spins, your challenge is to aim a brick into the basket. Once again, video down the entire process and upload it into the assessment box in Seesaw. We'll be once again voting for the best model. So today, a quick recap. We have covered on what is friction, the 2 types of friction, which are rolling friction and sliding friction. And we also covered a mathematical formula for perimeter, which is the length of all the sides. I hope you learned something new this lesson, and we come to the end of lesson 3. See you next time. Goodbye.